We're doing 2.7, proving statements about angles. You're going to use angle congruency properties to prove properties about special pairs of angles. Right angle congruency theorem, we already talked about this. All right angles have to be congruent. Congruent supplements theorem, if two angles are supplementary to the same angle, they are congruent to each other. Congruent supplements theorem, congruent complements theorem, if two angles are complementary to the same angle, then they are congruent to each other. You know linear pair postulate and you know vertical angle. So we're going to use all of those to do these next three proofs. Okay, so we're looking at example 1. And look, you don't even have to try to interpret my crazy handwriting. All right. Angle 1 and angle 2 are complementary.
Do we tell me that I can use symbols?
You can use symbols. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. This is given. Let me see if I can make this a little bit bigger. Okay, I'm just trying to make it bigger and it divide correctly. Computers are crazy. All right. There we go. Okay, hopefully that's bigger. Number 2, the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4 by definition of congruency. So we changed them from congruent to equals.
We could have M and then the angle.
Yeah. Yep, you can go like this instead. So all I did was take out the congruent symbols, because like up here it's 1, angle 1 is congruent to angle 3, and we changed it to the measure of angle 1 is equal to the measure of angle 3. Definition of congruency.
Wait, so which one do we write?
You write down the whole thing. Angle 1 and angle 2 are complementary angles. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Number 2, we changed it so that the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4. That's by definition of congruency.
So we write both of those?
Yes. One is the symbolic way, one is as if I was saying it out loud.
So does it matter which one?
No. The measure of angle 3 plus the measure of angle 4 equals 90 degrees. This is substitution. I know that 2 and 4 are equal and 1 and 3 are equal, and I know that 1 and 2 are complementary. So I did substitution. The measure of angle 1 plus the measure of angle 4 equals 90. Then I've got angle 3 and angle 4 are complementary by the definition of complementary. So you want me to go over that again?
I want you to look at
Yeah.
What did you say? What?
I'm going to look at the picture real fast. I'm going to go back to the picture. You guys keep writing this down.
Can you repeat forward the last one?
Hold on. Angle 1 and angle 2 form 90 degrees. Okay? We know that angle 1 and angle 3 are congruent. And we know that angle 2 and angle 4 are congruent. And what I'm trying to prove is that 3 and 4 are complementary. So the first thing I did is wrote down all the givens. The givens right above it, you can write it down just like that. Then I used definition of congruence to change it from congruent to equal. Okay?
Why would you do that so we can change it to the
So that I can plug it into an equation.
also like the measurement of angle 1, because it says the measurement of angle 1 is congruent to measurement of angle 3.
Now you changed it from congruent to equals, yes.
So
That's why we use definition of congruency.
we're changing it back and forth.
Yes. Okay. So the measure of angle 3 plus the measure of angle 4 equals 90 degrees. This is by substitution. Therefore, angle 3 and angle 4 are complementary by definition of complementary. Okay? I'm going to turn it over, and we're going to look at example 2.
This is kind of like the last lesson.
This is kind of like what? The last lesson? Yes.
What are we learning differently?
It's pretty much just going over the same thing again.
Why do you do that?
Because each of these things are typed in separately, because I have to use a certain special program to make the vertical line. Okay. So we're proving, we're given that angle 6 and angle 7 are congruent to each other. Angle 6 and angle 7, we're given that are congruent. And we want to prove that 5 and 8 are congruent to each other.
Let's just let that one out.
Yep. I might be doing this again, hint, hint, because they look very similar to your test. Yes, Chris.
Okay, so like on the quiz, like you know how like you have the 2-column thing and have like 1 through 6. Well, we use every single one of those.
No.
sections.
So we know angle 6 is congruent to angle 7, and that's given. We know angle 5 is congruent to angle 6 by vertical angles, right? These two right here, congruent to each other by vertical angles. Then we can say by transitive 5 is congruent to 7. Then we know 7 is congruent to 8 by vertical angles. And finally we know 5 is congruent to 8 by transitive.
Wait, so can you repeat all those?
We're given that 6 is congruent to 7. Given. 5 is congruent to 6 by vertical angles.
Miss Murphy,
Yes.
I have a question. If they give that to us, why do we prove it?
You have to, they give you 6 is congruent to 7, you have to prove that 5 is congruent to 8.
Oh, okay. I see.
How did you get that? Angle 5 is congruent to angle 7. Isn't it because they're both the?
Well, you've got 6 is congruent to 7, and 5 is congruent to 6. So see how they both have 6 that have in common? Therefore, they have to be congruent to each other. It's transitive. A equals B, and B equals C. Then A equals C. Okay? And then 7 is congruent to 8 by vertical angles. Therefore, 5 is congruent to 8.
Alright, so like,
Oh, because there are 2 7s before that.
Yes. Because of they have this 7 in common and this 7 in common. Therefore, 8 has to be congruent to 5. Yes.
On that plan for proof thing,
Yes.
angle 5, I mean, you know, it says then use transitivity to show that angle
Yes.
5 is so we have to, the reason always is going to be transitive for,
For a problem like this, yes. Not always going to be true if I change the numbers or put them in a different way.
but for all angles, it's always going to be
No.
transitive. Okay, all right.
Yes.
I was just gonna ask like, what if we had the same sets but they were just in different orders?
They've got to be in the right order. It makes a big deal.
So
It's a
like,
big deal.
like it says given and then it has vertical angle and then transitive and vertical.
Yes.
What if we put given versus
I would take a point off,
vertical?
or half a point off. They're in the wrong order.
Like how would we know what order?
It's got to be logical. So I've got to prove that the vertical angles are transitive before I can move on to this vertical angle to prove this transitive. I can't prove this transitivity until this transitivity has been proven up here. It's hard. I understand. Okay, let's go to one more. We've done this one before as well. Okay. All right. Look at this line. That's really bad. All right. Angle BGH and angle CHG are supplementary. That's given. We know that the measure of angle BGH plus the measure of angle CHG is 180. That's definition of supplementary. Stephen, would you open the door for anything?
I'm
Then we know by linear pair postulate that BGA and BGH,
Can you slow down?
yes. Here, let me show you with the picture. We know that these two angles right here form a what? Linear pair. Okay. And then by transitivity, we know that BGA is congruent to CHC. This is very, very similar, if not exactly the same, to 2.6D. I am going over it again because I feel like you guys missed parts of these